Although we may not realize it, our daily lives are full of products and systems that were first developed for exploring space. All the way from instant powdered juice drinks and top-of-the-line sports equipment to satellites that allow us to talk to friends who live far away. We rely on space-age technology in many types of ways. Satellites, sometimes referred to as artificial satellites, are objects that are built and sent into Earth's orbit by humans. A natural satellite refers to any small body that orbits a larger body, such as a moon or an orbiting planet. Looking like small spherical containers or snap-together toy structures, these relatively small objects are loaded with electronic equipment, digital imaging apparatus, and other instrumentation. They transmit the information they receive to ground stations by radio waves, a topic that we'll learn more about in Section 3.0. Satellites play a major role in our lives, performing a variety of functions from space. They can help us communicate, observe and forecast weather, predict magnetic storms, and even find our location on the planet. We send satellites into space to allow us to watch television and make long-distance phone calls. Some newer cars even come equipped with satellite tracking devices. Computers in these cars receive satellite signals. And this information is then relayed to the driver as directions to the nearest gas station or a particular address.
Orbiting 36,000 kilometers above the ground, geostationary satellites rotate at the same speed as our planet, following its movement while always remaining above the same point on the equator. To an observer on the ground, this makes them seem perfectly motionless in the sky. In actual fact, they move at over 3 kilometers per second without using any fuel, maintaining their initial speed in the vacuum of space. In geostationary orbit, Eutelsat operates a fleet of satellites which cover 2/3 of the planet. Thanks to their position high in the sky, satellites are the essential complement to land-based networks. This enables them to avoid obstacles in the landscape and to connect an infinite number of sites across the Earth. Satellites could be called the network of all networks. They are the favoured means of broadcasting television programmes to households equipped with satellite dishes or through networks which themselves rely on satellite feeds. In addition to television, satellites also enable high-speed internet connection even in the most remote areas. A rocket can launch a satellite into space and reach its transfer orbit of 1,500 kilometers above the ground within 30 to 40 minutes. The satellite then deploys a section of its solar panels in order to provide a steady power supply during its travel in space. Engine propulsion is used to gradually make its orbit more circular until it describes a perfect circle and attains its final position in geostationary orbit. Once in position, the satellite fully deploys its solar panels and antennas, producing a wingspan of 40 meters. 3 to 4 weeks have passed since the satellite left Earth. Space vacuum, radiation, extreme thermal conditions of -150 to 150 degrees. Satellites are high-technology equipment designed to function for over 15 years in a hostile environment. All telecommunication satellites are built for the same purpose, to receive a ground signal and transmit it inside their coverage area. The signal is sent from a transmitting station, which can transport television programs or data, or establish an internet connection. In order to repeat the received signal across the entire coverage area, the satellite must re-amplify it and change its frequency. This is carried out by transponders, amplification tubes located between the satellite's reception and transmission antennas. All the equipment is fastened to a central pod. Radiated surfaces evacuate any heat produced, and heat shields insulate the satellite from the outside environment. In addition to the control systems, the pod houses the propulsion system and fuel tanks. This system maintains the satellite at its station and reduces disturbances related to the attraction of the Sun and the Moon and Earth's gravitational field. The 2 solar panels supply all the energy required for the satellite to fully function throughout its lifetime. This makes the satellite the most environmentally friendly means of communication. Each equinox, when the satellite moves to the Earth's shadow, rechargeable batteries take over.
In the early part of the 20th century, telegraph and telephone communication across the North American continent traveled through wires. Cable connections needed to be physically in place in order for one person to talk to another person. This was a difficult and very expensive process, even on land. Setting up telephone communication with someone across an ocean was a much greater challenge that required the laying of submarine cables. Communication satellites have eliminated the need for the costly cable laying. Today, satellites use digital systems that result in clearer transmissions and allow for a great number of users at any one time. Every nation in the world now employs wireless technologies for a wide range of communications. Observation satellites can do more than just take photographs and monitor weather. 2 Canadian satellites, Landsat and RadarSat, have been used to follow ships at sea, monitor soil quality, track forest fires, report on environmental change, and search for natural resources. RadarSat sees more than 1 million kilometers squared of Earth in each of its orbits. These satellites are not in geosynchronous orbit. The main purpose of satellites in low Earth orbit, at about 200 to 1,000 kilometers altitude, is to carry out remote sensing. Remote sensing is a process in which imaging devices in a satellite make observations of Earth's surface and send this information back to Earth. Images can be photographs taken by cameras or data collected from the sensing of heat and other invisible energy waves. Remote sensing can provide information on the condition of the environment on Earth, natural resources, and effects of urbanization. This information is used for planning. Imagine always knowing your position on the planet, accurate to within a few meters even. The Global Positioning System, or GPS, lets you do just that. This technology was designed to give people, wherever they are, their location on the ground at any given time. 24-hour GPS satellites are in orbit around Earth, which means that at least 3 are above any given location in the world at any given moment. Radio signals from the satellites are picked up by a handheld receiver, which is about the size of a small handheld video game. The signals are then translated by a computer in the receiver, which then shows on a digital display the operator's position in relation to the satellites. Many items, materials, and systems originally designed for a space application have been put to practical use on Earth. Innovations to help us study our universe, travel out into it, or exist in the space environment can be found today in just about every aspect of our lives.